There's a semi-truck parked at a test facility in Lisle, Illinois that looks like a regular international tractor got stretched and smoothed inside a wind tunnel until every hard edge disappeared. It weighs 65,000 pounds loaded, and according to road test data verified by the United States Department of Energy, it moves each ton of cargo it carries using less fuel than your car uses to move you to the grocery store. That should not be possible. A loaded 18-wheeler pushing through the air at highway speed is one of the least efficient things on the road, and yet the numbers from this truck are real and measured. Today we're talking about the International SuperTruck II, and the 10 years of engineering it took to make a 30-ton machine sip fuel like a sedan. So where does a truck like this actually come from? Not from a normal product program, that's for sure. The story starts with a problem that's been staring at the American economy for decades. Heavy trucks, the big Class 8 tractor trailers hauling freight on the interstate, make up only about 4% of the vehicles on U.S. roads. But because they run hundreds of thousands of miles and haul tens of thousands of pounds, they burn a wildly outsized share of the fuel. The average Class 8 semi in America gets about 7.24 miles per gallon. Your pickup truck laughs at that number. And when diesel prices spike, that 7 miles per gallon flows straight into the price of everything you buy because in America, if you bought it, a truck brought it. Keep that 7.24 in your head and keep your skepticism handy too. Before this video is over, we're going to put the truck up against your car with a calculator, and the result is not close, just not in the direction you'd expect. So back in 2009, the Department of Energy launched something called the SuperTruck program. The idea was simple and a little bit crazy. The government would hand the big truck manufacturers serious research money, around $20 million per team, and each manufacturer would match that with their own money. In exchange, the teams had to build real, drivable demonstration trucks that shattered the efficiency of a 2009 baseline vehicle. Not paper studies or wind tunnel models, but actual trucks on actual highways with actual trailers full of weight. Freightliner signed on, Volvo signed on. Peterbilt teamed up with Cummins. Kenworth and their parent company, Packard, joined. And so did Navistar, the company behind the International brand, one of the oldest names in American trucking. The first round of the program wrapped up around 2016, and the results turned heads across the industry. The best SuperTruck I demonstrators were hitting around 13 miles per gallon. Remember, the national average is barely above 7. Daimler announced more than a 115% improvement in overall freight efficiency over their 2009 baseline truck and crossed 50% engine brake thermal efficiency, a number the diesel world had been chasing for decades. The Peterbilt and Cummins team demonstrated a 66% fuel economy improvement on their demonstrator. The manufacturers had nearly doubled the fuel economy of a loaded semi-truck, and every team exceeded the government's targets. So the Department of Energy did what any good engineering organization does when a target gets beaten. They raised it. In 2016, SuperTruck II launched with an even more aggressive goal, more than doubling the freight efficiency of a 2009 truck. And Navistar's engineers in Lisle, Illinois spent the next 7 years building the machine this video is about. So what does the International SuperTruck II actually look like? Honestly, it looks like a truck from a science fiction movie that's trying very hard to pretend it's normal. The familiar International cab is still recognizable, but everything around it has melted into smooth, flowing bodywork. The front end tapers like the nose of a high-speed train. The gap between the tractor and the trailer, that big ugly air trap you see on every semi on the highway, is closed off and sealed. The underbody, normally a chaos of axles, tanks, and cross members churning up the air, is covered in smooth composite panels. Skirts run the full length of the trailer, and the back end tapers instead of ending in a flat vertical wall. Even the ride height changes. At highway speed, the truck can lower itself closer to the pavement to squeeze the air gap underneath. Why go to all that trouble? Because a conventional semi-truck has the aerodynamic profile of a barn door being pushed through the atmosphere at 65 miles per hour. Above about 50 miles per hour, aerodynamic drag becomes the single biggest force the engine has to fight, bigger than rolling resistance, bigger than the weight of the cargo on flat ground. And drag has a nasty habit built into the physics. It grows with the square of your speed, so a truck at 70 miles per hour is fighting nearly double the aerodynamic force it fights at 50. Every flat surface, every open gap, every exposed mirror and grab handle rips the airflow apart and creates turbulence, and turbulence is drag, and drag is fuel. Two spots on a normal semi are especially brutal. The first is that open canyon between the tractor and the trailer where crosswinds dive in and slam against the flat front wall of the box. The second is the back of the trailer, where the air that spent the whole trip clinging to the sides suddenly falls off a cliff edge and collapses into a swirling low-pressure wake that literally sucks the truck backward down the highway. Sealing the gap kills the first problem. Tapering the tail, the way the SuperTruck II does, lets the air close back together gently and shrinks that vacuum dragging on the rear doors. This is the exact same battle Auto Aviation fought with the Solera 500L airplane we covered previously, just fought on 18 wheels instead of 2 wings. You cannot cheat physics, but you can absolutely stop insulting it, and that's what the SuperTruck II bodywork does. Smooth the flow, seal the gaps, taper the tail, and the engine suddenly has dramatically less air to shove out of the way. But smoothing the bodywork only gets you halfway. The other half of this story lives under the hood, and it might be the most impressive diesel engine ever put in a truck. Let's talk about a number that sounds boring and absolutely is not. Brake thermal efficiency. In plain English, it's the percentage of the energy in your fuel that actually becomes useful power at the crankshaft instead of disappearing as waste heat. A typical gasoline car engine converts somewhere around 30 to 35% of its fuel into motion. The rest literally goes out the tailpipe and radiator as heat. A good modern heavy-duty diesel does better, maybe mid-40s. The engine in the International SuperTruck II demonstrated 55.2% brake thermal efficiency. Hold on to that number, because in a few minutes you're going to see what it does to a fuel bill. Jim Seigler, Navistar's chief engineer for advanced engines, said it took a full system approach to get there, and that phrase is doing a lot of work. The team redesigned the cylinder head, moved to dual overhead camshafts, built an enhanced fuel injection system, and chased losses everywhere air and heat move through the engine: combustion, friction, gas exchange, airflow. Suppliers like Bosch, Jacobs Vehicle Systems, and Applied Nanosystems brought new technology to individual components. The exhaust aftertreatment system got its own overhaul too, with improved diesel exhaust fluid dosing, better mixing with lower flow restriction, and new selective catalytic reduction formulations that cut nitrogen oxide emissions harder and light off faster after a cold start. That matters because in a modern diesel, emissions equipment and fuel economy are usually enemies. Cleaning the exhaust normally costs you fuel, and Navistar's engineers found ways to do both at once. Each improvement sounds tiny on its own. A better cam here, lower friction there, smarter fuel dosing somewhere else, a catalyst that wakes up a few seconds sooner. Stack them all together, and you get an engine that wastes less than half of its fuel, which in the diesel world is elite territory. To put 55.2% in perspective, for over a century, the waste heat pouring out of engines has been the single largest energy loss in all of road transportation. This engine claws more of that heat back into forward motion than almost any piston engine ever strapped to a chassis. And then Navistar did something that surprised a lot of people in the industry. They made the truck a hybrid. Working with Bosch, the engineers built a high-voltage electrical system into the SuperTruck II. Accessories that normally steal power directly from the engine through belts and gears, things like cooling and air systems, were electrified so they only draw energy when they're actually needed. The hybrid system lets the diesel spend more of its life running at its most efficient point, while electricity handles the peaks and valleys. And there was a second, quieter motive here. Every high-voltage lesson learned on this truck feeds directly into the fully electric trucks Navistar knows are coming. The SuperTruck II is a diesel on the outside and a rolling electric vehicle laboratory underneath. Quick pause. If you enjoy deep dives into machines like this, the weird experimental hardware that the big channels never cover, hit subscribe. There's a lot more of this coming. Now back to the truck, because we haven't even talked about the smartest part yet. The trailer. This is the detail that separates Navistar from every other team in the program. Dean Opperman, the chief engineer on the project, pointed out that Navistar was the only manufacturer that built its own trailer for testing, and if you know trucking, you know why that's a big deal. A semi-truck is a system. The tractor and trailer travel as one aerodynamic object, but in the real world, they're built by completely different companies that barely talk to each other. The tractor maker optimizes their half, bolts it to a standard box trailer, and physics gets whatever mess results. Navistar refused to accept that split. Their SuperTruck II trailer has a 100% composite box, designed from scratch for minimum aerodynamic drag. The cross members that hold the floor together are integrated into the structure, instead of hanging underneath catching air. Composite aero treatments control the airflow along the entire underbody. The roof carries 6.7 kilowatts of solar panels feeding the electrical system, which is real power, enough to run the truck's electrified accessories and take load off the engine every time the sun is out. Even the trailer's ride height is controlled. It's lighter than a conventional trailer, so every pound saved in structure becomes a pound of paying cargo. It's slipperier than a conventional trailer, and it generates some of its own electricity while rolling down the interstate. Nobody sells a trailer like this. They had to build it, because the whole point of the program was finding out what happens when someone finally engineers the entire vehicle as one machine. So what happens? Let's get to the numbers, because this is where the SuperTruck II earns its name. In road testing on flatland duty cycles across Illinois, running at a gross vehicle weight of 65,000 pounds, the International SuperTruck II achieved 16 miles per gallon. 16. The average American semi gets 7.24. The best SuperTruck of the previous generation got 13. This truck beat the national average by more than double while hauling a full load, and overall, the project demonstrated a 170% improvement in freight efficiency compared to the 2009 baseline truck. Now, I know what some of you are thinking. 16 miles per gallon, my Toyota gets twice that. How exactly does this thing consume less fuel than a car? Fair question, and I promised you the math, so here it is. Fuel economy for freight isn't really about miles per gallon. It's about ton miles per gallon, meaning how much stuff you move how far on each gallon of fuel. Grab a calculator and follow along. The SuperTruck II hauls roughly 20 tons of cargo while burning 1 gallon every 16 miles. That works out to more than 300 ton miles per gallon. Now take a nice efficient sedan getting 32 miles per gallon carrying one 180-pound driver and a couple bags of groceries. Call it 1/10 of a ton of payload being generous. That's barely 3 ton miles per gallon. Per ton of cargo actually moved, the truck is roughly 100 times more fuel efficient than the car. Moving 1 ton of freight 1 mile in this truck takes a small fraction of the fuel it would take to move that same ton in any passenger vehicle ever built. That's what the title of this video means. And the wildest part is that it's not even close. And the money follows the math. Let's keep the calculator out. A typical long-haul truck covers around 100,000 miles a year. At the national average of 7.24 miles per gallon, that truck burns roughly 13,800 gallons of diesel annually. At 16 miles per gallon, the same year of work takes about 6,250 gallons. That's a difference of over 7,500 gallons per truck per year. With diesel at $4 a gallon, you're looking at roughly $30,000 saved annually on a single truck. Now think like a fleet manager. A mid-size carrier running 500 trucks would be saving something in the neighborhood of $15 million every single year on fuel alone. Scale that across the roughly 2 million tractor-trailers working American highways, and the numbers stop sounding like savings and start sounding like national economic policy. Fuel is typically the first or second biggest cost in trucking, fighting with driver wages for the top spot. Cut it in half and you don't just improve a business. You change what shipping costs for the entire country. Which brings us to the obvious question. If this truck exists, and the data is verified, and the savings are this enormous, why can't you drive down to your international dealer and order one? A few honest reasons. First, the SuperTruck II is a one-off research prototype, hand-built over 7 years with money specifically earmarked for pushing limits rather than turning profits. That composite trailer, the custom bodywork, the prototype engine internals, none of it was designed to roll off a production line at a price a freight company would pay. There's also the small matter of survival. A working trailer gets backed into loading docks, stabbed by forklifts, and slammed over potholes for 1 million miles. And nobody yet knows how a fully composite box holds up to 20 years of that abuse, or what it costs to repair one in a truck stop parking lot in Nebraska at 2 in the morning. Trucking is a business with razor-thin margins, and fleet owners buy proven, cheap, and fixable long before they buy clever. Second, some of the technology literally isn't street legal yet. Across the SuperTruck program, teams replaced the big, drag-inducing side mirrors with slim camera systems, and Volvo's team measured that swap alone, cutting drag by more than 4%. But federal regulations still require conventional mirrors from the factory, so that fuel saving sits on the shelf waiting for the rulebook to catch up. And third, this was never supposed to be a product. The entire purpose of a SuperTruck is to find out which technologies survive contact with the real road, which ones are worth the cost, and which ones belong in the trucks you'll actually see at truck stops 5 and 10 years from now. And that trickle down is already happening, which is the part of this story that actually matters for the future. Navistar took lessons straight from the SuperTruck program into the S13 integrated powertrain that went into the production International LT, a truck fleets can buy today. Predictive cruise control, the system that reads the terrain ahead and manages speed to save fuel over hills, was showcased on the SuperTruck II and is now spreading through production trucks across the industry. The high-voltage hybrid work with Bosch is feeding directly into electric truck development, and the Department of Energy looked at all of this and once again raised the bar. In 2021, they launched SuperTruck III, and this time the target isn't better diesel mileage at all. It's zero-emission freight, battery electric and hydrogen trucks capable of doing real long-haul work. Meanwhile, the North American Council for Freight Efficiency reviewed the whole second program and confirmed that all 5 manufacturer teams, Navistar, Freightliner, Volvo, the Peterbilt and Cummins partnership, and Kenworth, exceeded a 100% freight efficiency improvement over their 2009 baselines. Every single team more than doubled what a semi-truck could do with a gallon of diesel. Not one team failed. So here's where we land. The International SuperTruck II will never haul a paying load. It lives the quiet life of a demonstrator, rolled out for engineers, journalists, and government officials. But dismissing it as a science project misses the point completely. This truck is proof, measured on real Illinois highways with 65,000 pounds pressing on its axles, that the least glamorous vehicle in America still had more than double its efficiency left on the table. It proved a diesel engine can convert 55% of its fuel into useful work. It proved a trailer can be an aerodynamic partner instead of a brick on wheels. It proved that per ton of cargo moved, a properly engineered semi-truck embarrasses every car on the road. The 2009 baseline truck this program measured itself against got about 7 miles per gallon. The machine parked in Lysol gets 16, and the technology that made it possible is quietly climbing into the production trucks passing you on the interstate right now. So the next time an 18-wheeler rolls by and you think nothing about it has changed in 50 years, remember the smoothed-out International in Illinois that proved everything can change. If this story blew your mind, hit like, subscribe for more of the strangest engineering stories on the road and in the sky, and we'll see you in the next one.